Assalamualaikum. Our today's topic is types of adsorption. Dear students, as I have already rather explained it to you, uh, adsorption, it is mechanism how it takes place. Now, depending, and I have already told you about adsorbate, that it is the substance which gets accumulated on the surface of a solid, and the solid on whose surface this process takes place, adsorption takes place, that is called as adsorbent. Now, depending upon the nature of binding forces between the adsorbate and the adsorbent, we have got two types of adsorptions. One type of adsorption that is called as physical adsorption, and the another type that is called as chemisorption. Now, as far as this physical adsorption is concerned, now in this case, and in case of this, in this case, we see the adsorbate. It gets adsorbed on the surface of the adsorbent by means of physical forces like van der Waals forces. That means the gas gets attached to the surface or to the solid surface by means of these physical forces. Whereas in case of this chemical adsorption, it is a type of adsorption in which the binding force between the adsorbate and the surface of the solid, that is like strong chemical bonds are involved in this case. Now, if we make a comparison of these two processes, that is physical adsorption and this chemical adsorption or chemisorption. One is in case of a physical adsorption, we see that the attractive forces or the binding forces between the adsorbate and the surface of the solid, that is they are physical forces like van der Waals forces. Now, in this case, we see the binding forces between the adsorbate and the surface of the adsorbent. They are chemical forces like chemical bonds. Now, in this, in case of this physical adsorption, we see that this process, it is exothermic in nature. That means when this physical adsorption occurs, there is evolution of heat. So this physical adsorption, it takes place, rather it is favored by low temperature. That means if we decrease the temperature, the rate of this physical adsorption increases. However, if we increase the temperature, then this physical adsorption gets rather it gets decreased. And the enthalpy of adsorption, that is the amount of heat which is given out when a unit ml of a particular gas gets adsorbed on the surface of the solid. Now, as far as this chemi adsorption is concerned, we see that this in this case, in the case of chemical adsorption, as the attractive forces or the binding force is a chemical bond. So in this case, this adsorption, this chemical adsorption, it increases with increase in temperature. And because in this case, we see it is the heat of this adsorption or the enthalpy of adsorption, it is about 200 to 400 kilojoules per mole, while that of this enthalpy of adsorption for this physical adsorption, it is 20 to 40 this kilojoules per mole. Now, this physical adsorption, it is a reversible process. That means we can also remove the adsorbate from the surface of the of this solid, or the surface of the adsorption of this of the adsorbent, by increasing the temperature. The process of removal of this adsorbate from the surface of this adsorbent that is called as desorption. While as this chemical adsorption or chemisorption, it is irreversible. That means we cannot remove the adsorbate from the surface of the adsorbent. Now, in this case, in case of physical adsorption, the extent of adsorption increases and with the ease of liquefaction and liquefaction of the gases. So that means the extent of adsorption increases with ease in liquefaction, or rather it depends upon the ease of liquefaction of the gas. While as in case of chemiadsorption, there is no relation between the extent of adsorption and this ease of liquefaction of the gas. Now, as far as this physical adsorption is concerned, it is not specific. This type of adsorption, it is not specific. That means all the gases are adsorbed on the surface of the adsorbent to about the same extent. Whereas this chemical adsorption, it is highly specific, as it involves the formation of a chemical bond between this adsorbate and the adsorbent. Now, another point of the difference between this, that is the state of the adsorbate is same. Now, in this case, the state of the adsorbate is same as in bulk. But in this case, the state of the adsorbate is not same as in bulk. This is because that since there is a formation of a chemical bond, there is a formation of a chemical bond between the adsorbate and the adsorbent. For example, oxygen, it may exist as molecular O2 in case of in bulk, while as on the surface of the adsorbate on the surface of the adsorbent, it may exist as O2 minus or O2 divalent negative, or it may be in atomic form, that is O. No, so the state of the adsorbate is not same as in bulk and that on the surface of the adsorbent. Now, another point of difference between the two is that this physical adsorption, in this case we see that it forms a multimolecular layer. The adsorbate forms a multimolecular layer on the surface of the adsorbent, whereas in case of chemiabsorption we see that there is a monomolecular layer which is found on the surface of the adsorbent. Another point of difference between the two is that this physical adsorption, in this case, if we increase the pressure of the adsorbate, the rate of this rate of adsorption may get increased. It may increase the rate of adsorption, whereas in case of a chemisorption, the rate of adsorption may get decreased. That means this decreases with increase in pressure. So this is a comparison between physical adsorption and this chemical adsorption. Now, as far as the adsorption of gases on the surface of the solids is concerned, the extent we see that the gases, they get adsorbed on finely divided metals, transition metals, like we got platinum, palladium, and we got this nickel. Now the extent of adsorption on the surface of these solids, or the extent of rather adsorption of gases on the surface of the solids is affected by following factors. Number one, we have got the nature of the gas, we have got the nature of the adsorbent, we have got the effect of this pressure, we have got effect of temperature, and we have got the activation of the adsorbent. Now, as far as this nature of the nature of this gas or nature of the adsorbate is concerned, the extent of this adsorption of gases on the surface of a solid, it depends upon the nature of the gas. For example, we see the easily liquefiable gases like HCl, we got this ammonia and chlorine. They are adsorbed to a greater extent on the surface of the solids as compared to the gases which do not get easily liquefied. Like we got this hydrogen, chlorine and oxygen. Now the ease of liquefaction of a particular gas, it depends upon the critical temperature. Now what is this critical temperature? This critical temperature, it is the minimum temperature of a gas above which the liquefaction of the gas does not take place, however high pressure may be applied. So higher the critical temperature of a particular gas, the more easily it will get liquefied, and the more readily it will get adsorbed on the surface of a solid or on the surface of the adsorbent. Now here I will show you that 1 gram of activated charcoal 1 gram of activated charcoal can absorb following amounts of these gases can absorb the following amounts of these gases depending upon their critical temperatures. Now for example, if we take the example sulfur dioxide, it has got a critical temperature of 430. Now the amount of the gas adsorbed is 380 ml, whereas if we take the example of ammonia, which has got a critical temperature of 406 Kelvin, now the amount of gas adsorbed is it is about 180 ml. 180 ml. Now in case of carbon dioxide, we see the critical temperature is 304 and the amount of gas adsorbed is 48. Now in case of methane, the critical temperature is 190 Kelvin and the amount of gas adsorbed is 16.2 ml. Now in case of carbon monoxide, we see the critical temperature, it is 134 and the amount of gas adsorbed is 9.3 ml. 9.3 ml. Similarly, in case of nitrogen, the critical temperature is 126 Kelvin and the amount of gas adsorbed is 8 ml. Similarly, in case of hydrogen, we see the critical temperature is 33 Kelvin and the amount of gas adsorbed is 4.5 ml. So now we see how this critical temperature plays a very important role in case of adsorption. Now we see the higher the critical temperature of a particular adsorbate, the more readily it will get liquefied and greater is the extent of adsorption. Now the another factor which is responsible or which affects this extent of adsorption is the nature of the adsorbent. Now as far as the adsorbents are concerned, nature of adsorbent, it also plays a very important role. Because the extent of adsorption, this adsorption also depends upon the nature of the adsorbent. That is, it depends upon the nature of the solid surface on which adsorption takes place. For example, easily this activated, for example, I will give you an example of activated charcoal. This activated charcoal absorbs these easily liquefiable gases to a greater extent. For example, now this activated charcoal, it can be used in the adsorption of rather it is used to absorb the poisonous gases present in the laboratory, or it can be used at any place. It can be used as an adsorbent to absorb these poisonous gases. Now the gases like hydrogen, nitrogen and oxygen, they are adsorbed on finely divided transition metals like nickel, like nickel, palladium, we have got this platinum. So these gases get more adsorbed on these finely divided transition metals, because the finely divided, once these metals are finely divided, it increases the available available surface area. That means once the surface area gets increases, the amount of these the residual forces also get increased. Another factor that is the effect of this pressure, that inshallah we will discuss in the next top in next lecture. And this is all for today. Thank you very much.